cyclones, weather, rainfall and all. So I take this privilege to introduce Madam. Madam is Dr. Manorama Mohanty. She is the head IMD Bhubaneswar and she is the scientist at holding the position. And she is very proactive and whatever happens, it may be your summer times, rain season, cyclone times. As we can see, Dr. Mahatma sir, national level. So Madam is for our Odisha. So without any delay, now I welcome Madam to deliver this talk. So let us give a big round of applause.
A very good morning to all of you. Myself, Manorama, Madam, has given a nice introduction. Thank you, Madam.
Madam, sir, touch screen me. I'm not check
Okay,
otherwise he will operate.
Odisha is a state located in such a position where out of 12 months, 10 months we get bad. Like right side is Bengal, here it is Chhattisgarh, there it is Jharkhand, then down Andhra Pradesh. So always there is bad weather because of the dry air and humid air convergence. So because of which we also get lot of thunderstorm activity and weather phenomena. Because of the presence of Bay of Bengal, we get the system first. Because monsoon, during monsoon, all the system they form over Bay of Bengal, and because of that system and its movement, entire India receives rainfall activity. And we are the first one to get the activity. So our extreme weather over Odisha, especially I discuss about the Odisha weather activity in Odisha, cyclone, then heavy rain due to cyclone, due to monsoon, during the monsoon period which leads flooding, even the dry flooding. And if there is any dam burst or any part they release the water, Odisha gets flooding. And thunderstorm, lightning, then hailstorm, drought, heat wave. Cold wave is very rare. So winter we don't face much winter, but summer, extreme summer we face extreme weather activity also we face. Next. Then because of which we give forecast for all the 365 days, and it is a continuous process, and we give forecast for tropical cyclone during post-monsoon and pre-monsoon. Pre-monsoon means before the monsoon, like May, June, and post-monsoon means October, November, we get cyclone activity. And during monsoon, June, July, August, September, all the monsoonal system forms, because of which we get extreme weather activity. And after that, during summer, we get heat wave, we get hot and humid condition, we get thunderstorm activity, lightning, and winter we get low temperature warning and we get cold weather conditions. So throughout the year we get either of the bad weather. Next. So for that now we give the forecast. One we give the climate level forecast for the next decade. What will be the temperature, rise of temperature, or rainfall activity is going to increase or not, that way. And next stage is the seasonal range forecast, like long range forecast. For monsoon, how much rainfall will be there during the monsoon, or during summer, whether it will be a hot summer or it will be normal summer, and during winter also, whether it will be cold winter or normal winter. That way we give the seasonal forecast for next 3 months or 4 months like that. Then medium and then extended range forecast. We give by the forecast for next 4 weeks. For next 2 weeks generally it becomes correct up to certain extent. So we give that weekly forecast because planners that long range forecast, okay, monsoon will be good for the Odisha. Then they see the extended range forecast in which week we are going to get rainfall activity, whether that activity is continuing or next week we are not going to get any rainfall activity. So accordingly they plan for their sowing or for any watering purpose or any or for fertilizer. So they see the extended range forecast and they take the decision accordingly. Then we give the forecast for next 10 days. What will be the weather? So next 10 days we give forecast for next 10 days and we give warning. Heavy rainfall warning, heat wave warning, cold wave warning, wind warning, all this warning for next 7 days. And in addition to that, we give short range forecast for next 2 or 3 days. Still we go wrong. We tell that thunderstorm activity will be there for this district, for Mayurbhanj district, for Bhubaneswar district, but we do not know at what location it is going to happen, because entire district we cover before 5 days. This is the orange color, this is the red color, this is the yellow color, like that. But we cannot tell. As of now, science is not that developed. Our modelers are trying to develop their model in such a high resolution so that they will come, will give pinpoint forecast before 5 days or before 6 days, that it should be correct. Now also we are issuing the location specific forecast that may not be correct. But for that we are giving nowcast. Nowcast we are giving just before 3 hours. Just before 3 hours we are giving that in the Mayurbhanj district, these are the location where we are going to get thunderstorm activity or rainfall, heavy rainfall or moderate rainfall. Like that, I'll discuss how we are giving next. So this workshop is specifically it is focused on the numerical weather prediction model. So we'll discuss how IMD is using in NWB model, and in our IMD we use a short range forecasting model like weather research forecast model, that is WRF model. We have hurricane WRF model. That model will decide the track of the cyclone and our intensity of the cyclone. That is only after the formation of low pressure or depression that model we run hurricane weather research forecast model. Then medium range forecast, that forecast we get for next 10 days. And then extended range forecast I said that for next 4 weeks. And it has the different resolution. WRF model resolution is very high, that is 3 km by 3 km. And GFS, and we have a Bharat forecast system. Just recently it has been launched, and that resolution is 6 km by 6 km. That's a very good model. But model has its own limitations. Model cannot give you the clear-cut idea where we are going to get the extreme heavy rain. That will give indication. We are going to, for next 10 days, we are going to get rainfall activity from which day. But model has its own limitation. Next 5 days we can get, to certain extent we can get some indication, but 6-7 days it is very difficult to rely on the model also. Next. So these are the data set we are using for the data assimilation to take that as an input for the model. You all are science students. So I think everybody must have told you how they decide the model equation, like how to calculate the velocity in 3 direction x, y, z, and with respect to time. We have to integrate the equation with respect to time, so that if we integrate the equation like du is equal to something, like force is equal to mass into acceleration, acceleration is du by dt, and from that du we integrate with respect to time, du is equal to mass by force by mass into dt, then integration. So we integrate for next 24 hours, next 40, like that we integrate for next 10 days, and we get the model output. And to integrate, we have to 0 to 24. 0 value we should have, then only we can get the value after 24 hours. So for that 0 value, we do the data assimilation, which everybody is teaching. And for the data assimilation, mostly we have the observatory over the land area, but there is a vast area over the ocean where we do not have the large density of data set. So for that we take the satellite observation, like satellite data, radar data, and rather we say this is a remote sensing data, that we prepare a flat data set, and we use that data set as the initial condition. We subtract, like if you want to u1 minus u0 is equal to something, U1 we have to calculate and U0 value we should have. So that these data set we use as the initial conditions and we calculate for next 24 hours, 48 hours, 72 hours like that. So this is the way we are using all these data sets, laboratory data, reflectivity profile, then we have surface oxygen data, we have operator data, we have satellite data, and those all the data we do the value addition, we do the quality check because sometimes somebody they write 45, 39 instead of 3993. So that way we have to do the quality check. So because all the data after quality check only they can go to model as a input. If data is wrong, then forecast will definitely go wrong. If there is a minor mistake, then entire forecast goes wrong. Till today, we are referring models, various models, but till today not a single model is giving accurate forecast because the data, whatever we are supplying, that may not be so accurate. And also we are parameterizing various processes are there. Some in tropical country it is not that easy to capture to catch the weather. So we are struggling, and of course we have improved a lot. Our numerical models have also improved. Next.
कोई चेंज है लेवल मैंने से दिख के देखी कतरा पकड़े
So it is not that easy to give a forecast or to develop a model also. You have to work like anything. You have to see all these conditions. Even over the plain area, the things is different. Parameterization is different. Physics is different. If you go to hilly area, their physics is different. If you go to ocean area, their physics is different. So we have to incorporate all these things. Land, ocean, hill area, jungle, trees, everything we have to incorporate in our model to get a better forecast. So after doing all these 10 models, we refer every day. In addition to that, our observation is the most important parameter. Observations and satellite imagery, radar image, and all these things after doing analysis, also we don't go 100% correct forecast. That is always limitation is there in our science. So many scientists are there trying their level best to improve the models. It is improving also. People are really working very hard to improve the weather system of India. Because this is a tropical country. But people always compare USA and all these things. They are subtropical, we are tropical. Tropical country, one flip-flop of butterfly can create a turbulence. So it is not that easy to give a forecast and to give a accurate, 100% accurate forecast. It is very difficult. But the day will come, you people will work, you will get the level up to 100%. Okay, so there are various models.
स्टोर हो जिन नेट स्टोर हो तो सच्ची यहाँ के कुछ
Okay, ठीक है. So what we do basically, we refer all this model, and some model, one model will tell one cyclone is going to hit Andhra, another model it will tell it is going to hit Bangladesh, and another, because we have 10 models, one model will come, it is going to hit Odisha. So we should not take the decision by seeing a single model. we have to see the multi-model ensemble.
Madam, slow slide it.
Okay. Please slow.
Full slide.
Okay, here. So we have in our website all the models are there. Okay, let me complete from here. स्लाइड शो कर दी छे
हां सेट कंट्रोल हो पता नहीं
एक वेट करो
नहीं वो नीचे चूंगी ना
हां
पहुंच गया हां ओके
Okay, so in our website we have all these models, short-range model, medium-range forecast model, and extended-range forecast model. Then we have long-range forecast model. So all these models, for example, we have 10 numerical weather prediction model. Out of that, best we choose which one is matching with our observation, with our forecast. So those best model we take their average, ensemble mean, and this is the ensemble mean. Right? And if we see ensemble mean value and actual observation, they are almost matching. But some model is showing this is the spread. So if it is temperature, some model is telling temperature will be this much degree. Another model is showing temperature will be this much. So because we are taking ensemble mean. That is multi-model ensemble. Many model we take and we take that mean value and we have checked that mean value is this blue color and our actual observation is red color. So there is little variation. So we can rely on multi-model ensemble value. So we use most of the time MME, multi-model ensemble forecast model for the forecast. So we have many models like short-range forecast for Bharat forecast recently it has we have launched, and then we have medium-range forecast, we have extended-range forecast. In these products, we refer each and every product to give a single forecast. So we refer all these model forecast in that wind is there, wind forecast is there, rainfall forecast is there. Temperature forecast is there, minimum temperature, maximum temperature, all humidity, everything is there. Everything we refer, we finally get a conclusion what to give. That decision is very tough. Whether cyclone is going to hit Odisha or Andhra. This decision, because see, one model is telling, for example, one model is telling it will go to Andhra, another model it is telling it is going to Odisha. Then the next model is telling it is going to Bangladesh. So how we will take the decision? But here media people they will take one model and then it is hitting to Odisha near Paradip, Falana, everything. But we cannot give such information. We have to see all this information. In addition to this, we have many satellite parameters like sea surface temperature, OLR, and what is the potential energy, what is the kinetic energy. All these things by seeing, we finally give a conclusion that it is going to cross near Andhra Pradesh or somewhere. So that decision to take, it is very tough decision to give, because accordingly government will take the action. Because lot of money matters is there, money involvement is there, lot of financial involvement is there, and in that they have to evacuate the people also. So lot of financial activity will be there. We cannot say that it is going to without this, by seeing only one model we cannot say it is going to hit Odisha or Bangladesh. We have to see many parameters to give a conclusion. So this is the model what recently it has been developed, and we see the location of the low pressure system, how it is moving, because as I said, all the system, any low pressure system, they form over the Bay of Bengal and move across Odisha. So Odisha is the state who gets first bad weather if any system forms over Bay of Bengal this way. This is the model forecast for the rainfall forecast. So by seeing all this system movement, location and rainfall forecast, we give the district level forecast for the state Odisha. So this is the, we have these 9 models are there. All models we see and where it is, the system is coming, how it is behaving, rainfall pattern, how it is behaving. So accordingly, we first we refer all this model to see for the next 10 days, and which model is closely matching to our observations, where location of the center of the system. So in that way, we evaluate with the model and we finally give the forecast. Then also model gives quantitatively rainfall for Odisha. Next. It is not good. Do you know that it is fine? Okay, next. Okay. So also we have the 10 models. 1, 2, 3, 4, 5, 6, 7, 8, it is here. 8, yes. Okay. So in that we have 8 models and we have that multi-model ensemble value. We always try to accept that multi-model, but sometimes that also fails. We have to then physically we see where is the system, where is the pressure, where the pressure is lowest, and where it is going to move as per the wind direction. And by anticipating that, we give the forecast where extremely heavy rainfall is likely.
Then, fundamental how why tropics are extra tropics?
That's already I have discussed. Because here it is tropical country, temperature is very high. If you have lot of energy, you can do anything. If you don't have energy, you cannot do anything. You cannot think of also. But in tropics, lot of heating is there, lot of energy is there. So anytime, अगर आपका पास पैसा है, आपका पास हथियार है, आप किसी को भी मार सकते हैं. हाँ, अगर आपका पास कुछ नहीं है, पूरा ठंडा है, ना पैसा है, ना हथियार है, ना एनर्जी है, आपका पास कुछ नहीं है, आप कुछ नहीं कर सकते हो. So tropical country में यही weather भी it's kind of nature होगा, ऐसा ही होता है. So this is the way tropical area is most vulnerable for the extreme weather. So this is the way we get the values. What is the intensity of that rainfall? So here for Odisha, we get a single digit value, but we have to give district wise. People and you have to give the location specific. Bhubaneswar में वर्षा होगी नहीं. In the Bhubaneswar there will, or in the Cuttack there is some sai is there. In that sai there is rainfall will be there. People are demanding that marriage party is there, birthday party is there, some function is there. Whether the Janta Maidan where we are going to get rainfall or not. So that level people have the expectation, and we are able to provide the information within location specific, but not before 5 days or not before 7 days. On the same day, it is very easy to say if there is a system is there. If system is not there, we can tell before 10 days also. We are not going to get any rainfall activity. But if there is any active system is there, low pressure system or any upper air cyclonic circulation, then for us it is very difficult to say before 5 days if there will be rainfall activity over Pragati Maidan or over any area like that. So we have the marine product also. It is very important because all the fishermen and ports, all they move over the sea area. So we have to keep warning for them. For that also we are generating the model forecast. And we have many rivers because of riverine flood. Many rivers where we measure the water level. That we have the groundwater commission is there. CWC. They measure the water level based and they forecast also. Flood forecast they issue based on our rainfall forecast. So we also issue the forecast for all the rivers in Odisha, like 6 major rivers are there that for that Mohanty, like Mohanty and other rivers are there. We give the forecast for all the river basins also, and for that also model is there. We are able to get the model guidance. Then we have the meteogram. We have our this Meso-Scale on site is there in our IMD. Wherever you put the latitude longitude, you will get the forecast. That may be not 100% correct, but it will give an idea what will be the temperature, whether rainfall will be there or not. And this is the way you can get the information. This is the rainfall forecast. This is the forecast for temperature, and this is the way you can get the information in our location specific information. Next. Yes.
Yes.
Okay, so this is the way we run the model, like cyclone Taute. We have run the model. This is the way variation of track was there, and we have this is all model forecast, and this is the example track for the cyclone Taute, and this is the intensity of the cyclone of we calculate by using the model. But final decision is different, but one has to follow the refer the model forecast. Then only we take the final course. So this is the short range forecast for the whenever cyclone forms. A cyclone is going to form. It has the any low pressure system has formed. It has the potential to become a cyclone. And the moment low pressure or depression forms, then only we run the model to see where it is going to hit. The track forecast has a the intensity forecast. This is the short range forecast, that is Hurricane WRF model. That resolution is 3 km. And this is the thunderstorm and lightning. Those also model have been developed. We see where the thunderstorm lightning are happening. These are the area where lightning already happening. And in future also we can give, by seeing this, we can give the forecast for next 3 hours. Lightning already has started and it is going to start. Before that also we see all this model product, and also in addition to that we see whether really lightning is happening or not. Because to give, by sitting here to give forecast for Balasar, whether like cloud is there, all the clouds they don't produce the strong lightning, intense lightning. So we have to see these are the models already developed to see the lightning forecast. Accordingly, we have one app is there, Damini app. If you see that app where lightning is happening, you can get the information. This is also high resolution rapid forecast. When there is a bad weather is expected, we run this model and we get the information.
Yeah, which app?
Damini.
Tamil.
Damini. For the lightning. So this is the southwest monsoon. For southwest monsoon also we have the global forecast model. We have the Bharat forecast system. So by seeing all this model forecast, we see the this is the deviation, whether excess above normal rainfall anomaly. Anomaly means from the normal how much more. So normal it is more. This is normal is white. So plus this is plus 1,510. This is above normal rainfall activity we are going to get. So that way we give extremely heavy rainfall, very heavy rainfall, or heavy rainfall warning. Accordingly, we see all this product, then we issue the heavy rainfall warning. This is the during the cyclone Amphan, the track was also calculated, and also very important thing, we issue the extended range forecast for next 4 weeks. In that forecast also we get to know whether there is any vortex or any cyclogenesis is there or not. If cyclogenesis is moderate to high, then we expect that is cyclone will form or any depression, low pressure area will form. This is the model forecast. So here cyclogenesis, the probability of cyclogenesis is very high over here. So by seeing also before 15 days, we get to know that if any system is going to form, it may intensify into a depression or cyclone. This is a very good product we get from extended range forecast. Then this is the NCMRWF model, whatever he has already explained, I think. And these are the kind of forecast we get from NCMRWF also. We refer those models also. We forecaster, we refer all the models. If we see the system is near the Odisha coast, where it is going to get the rainfall activity. We know it is definitely it is going to give the rainfall activity over interior Odisha or coastal Odisha. And in which district it is going to get. But that is why we see all the models. Which model is showing where is the heavy rainfall. Then in addition to that, if we feel model is not underestimating the system, sometimes, many times radar models underestimate the system. It will give the rainfall spread, it will be there, but heavy rainfall it will not. So there we have to take our own decision. For that AIML will help us in our future. If system is here where we can get the heavy rainfall or extremely heavy rainfall, we have to see the topography. We have to see the geographical location, where is what, where is hilly area. So those area we have to, from the map we have to find out. And wind direction, where wind is getting low, where the wind is getting high. If it is wind is very low over here and hill area is there, then that by choosing these things we give the extremely heavy rainfall or very heavy rainfall in that particular district. Okay, this is the forecast guidance, that European model forecast, ICMWF forecast, that also we refer, and there also we get all these products, we also refer, there also meteogram is there for our GFS, they have also meteogram, so by seeing all these things like the digit of PM is there. You will go some remote area where we don't have any observatory. We have to give the forecast. How we will give the forecast? So we see all this. We give the latitude longitude. We see every model's forecast. And system we know. Okay, one low pressure system is there over Bay of Bengal, northwest Bay of Bengal. But exactly he is going to Manorama, some particular location. How to give the forecast? So we refer all these models. Then we use our science and location of the system, then always we give in the higher side. If there is any important event is there, we give one stage higher, not lower. If it doesn't happen, fine. But if we have not given it happen, then it's a problem. So we always give one stage higher. So this is the model analysis of pressure, where is low pressure, where is high pressure. Low pressure is always associated with the distant weather and high pressure is always associated with the fair weather. This is the EPS meteogram. So we refer location specific, where exactly we want the forecast. So this is this is ICMWF model forecast, that is issued ENS meteogram. So those things also we refer to see the rainfall, total cloud cover. From the cloud cover also we see the cloud image, we see the water vapor image, and we judge how much rainfall, precipitation estimate also we see, and we judge how much rainfall can happen. So accordingly, by seeing all this product, we give the forecast. So this is the Bharat system. We have a Bharat forecast recently launched. Resolution is 6 km by 6 km, and this is our GFS model wind. So this is the way we see the wind. By seeing the wind, it is very easy to give the forecast. Because this is wind means here it is anticyclonic circulation. That means we are not going to get any rainfall over this area. And if there is any, here one system is there, like one the cyclone is going to form over this area. So here also. So here this is a circulation kind of thing. Already deep depression is there. So it is going to into the cyclone. So by seeing the wind, it is easy to give the forecast, and this should be correct. by using the model forecast. Sometimes the model, that wind pattern is very much clear, but if we see corresponding rainfall, there will be no rainfall, hardly rainfall. So then we don't see the rainfall patterns. We see the wind product. As per the wind product, we give the forecast. It's not heavy rainfall, very heavy rainfall, or extreme rainfall. Then future direction is we have to increase the model resolution. As of now, it is 1 to 3 kilometer. We have to, for better local forecast like thunderstorm forecast, lightning forecast, we have to further reduce the resolution of the model. Then ensemble system for the uncertainty quantifications, then integration of AI, which is very important for our future generation and future weather forecast also. And high performing computing for more frequent update, because nowadays we are running the model 4 times a day or 2 times a day. And if it is a big model, then 2 times in a day, or if it is for region specific, then 4 times or 6 times sometimes. And cyclone times also 4 times we run the model. And if the computing system is very high, then we can go for the high resolution model, and also frequency of the running model will be high. Then this is the normal procedure for the forecast. Whatever I discussed, we give long range forecast in the month of April, first stage, then second stage we give in the month of May. In addition to that, we give the monthly outlook, forecast for rainfall, temperature, maximum temperature, minimum temperature. And if we consider the long range forecast for the year 2025, is the first in the first page we had told that above normal rainfall very likely for the country as a whole. Then second stage we say the forecast for the 4 homogeneous region, like this is northeast India, this is North India, this is central India, this is southern India. So these 4 homogeneous region we get the, but here if we see this blue color part here, that this is the rainfed area where the agriculture depends on the rainfall only, not much water facilities there for the agriculture. So this is the way. In addition to that, we also give the forecast for climate and mineral oscillation, and also other parameters. We also give the forecast. So that next. So this year, this year 2025, we have given that rainfall as a country as a whole will be more than 105% of its long period average. Our long period average has been 89 centimeter rainfall for the country as a whole. Out of 89 centimeters, we are likely to get 105%. That means 5% extra rainfall. Next. Realized also can just. And whenever we keep the forecast, we always verify that also. Whatever actual forecast. Realized rainfall, we received 937.2%, that is 8% excess. We expected 5% excess, but realized 8% excess. Similarly, for the probability of monsoon rainfall forecast, it was then that was during the month of April. For the planner, for the agriculture, for the farmer, we issue well in advance the long range forecast, because when we said excess or above normal rainfall we are going to get, the farmer they will plan what kind of sowing they will do, what kind of seed they will choose. So accordingly they decide. Then again also we revise that forecast in the month of May, and we also told we are likely to get good rainfall, excess above normal rainfall activity, but region wise for different region. Odisha also, if we see our South Odisha, it was showing that above normal rainfall, and North Odisha also normal to above normal rainfall. You were expecting next. So for Odisha, we were expecting above normal rainfall. Odisha, this is from June to September, and but we were expecting 106% above normal, but we only received the amount of rainfall, normal rainfall, 1150.2, exactly 1150.2. So our forecast, we should not say it is 100%. We had given the forecast, we are likely to receive more than 106%, but we exactly received 100%. Next. Similarly, this is the forecast for the month of June. We give the seasonal forecast, then monthly outlook. Monthly forecast also like that only. In the month of June, we are giving the forecast for the country as a whole. It will be all India long term average is 105.4%, 4 millimeters. So we had given that the June month will be the above normal rainfall, and it was realized. Next. Similarly for Odisha also, we also give Odisha. It was decided that more than 109% of long period average, and we received 117% rainfall. 9% more than 109 means it is 117% we realized in the month of June. Next. And July, similarly July. Next. August we had predicted deficient rainfall. This is August. This is something wrong. August it was predicted deficient rainfall and it has been realized. Next. Okay. This value has to be completed here. And September also it was predicted that cable normal rainfall activity, and finally actual rainfall happened this, normal this, and our season as a whole it is 0% departure means normal rainfall realized, though we predicted it will be more than 107%. Next. So this is the extended range forecast, first seasonal, then monthly, then extended range forecast means weekly forecast. This is the first week. First week we are expecting rainfall activity over entire Odisha. However, it will be above normal over this region, normal over this region, and this is below normal. Next. Next week also we are expecting rainfall activity to increase up to this, and this part only will deficient or below normal rainfall. But rainfall will be there because here it is showing rainfall is there. Entire state will get rainfall activity, but जितना होना चाहिए उतना नहीं होगा, उससे कम होगा. यहाँ जितना होना चाहिए उससे ज़्यादा होगा. Next. And this is the monsoon onset forecast also we give. Monsoon when it will have this onset over the Kerala. It was this year it was quite early, onset was quite early. That 24th of May entire Kerala and some part of Konkan it was covered, and Odisha also it was covered little early. 28th May or something, 26th May it came to Odisha. Then extended range forecast that I have discussed already. Next. This is the medium range forecast what we give the forecast. This means people actually they don't understand what we say. That's why I want to focus here. Here, this is the color. Here it is written scattered. Scattered means 25 to 50% area will get the rainfall activity. Rest of the area will not get rainfall activity. So, if there is all Odisha is there, here if we see all the stations, only 50% of the station will get rainfall activity, other stations they may not get rainfall activity. People say you have given rainfall means everywhere it will happen. No. Then here many places, 25% places we may not get rainfall activity, but many places will get the rainfall. This is the most places. This picture here it is 75 to 100% places will receive the rainfall activity. This is the spatial distribution. This way we create the map and we share with all this media and everywhere. Next. This is the wine. This is the heavy rainfall. This is orange color. Heavy rainfall with thunderstorm. since it is heavy rainfall with thunderstorm and lightning, generally we give color code orange for very heavy rainfall. But here we are expecting intense thunderstorm activity with heavy rain and also strong wind. That is why this belt we have kept orange color. And yellow color means there is thunderstorm activity there, strong wind will be there, that will not harm us much. But if orange color warning is given with thunderstorm activity, people should take action. But we have given the entire state, but that thunderstorm activity lightning will not happen the entire district. It will happen in some area of the district. But that is difficult for me to give before like this. I cannot give. On the same day only we cover those forecasts in nowcast. Next. This is the way we issue if there is any big system, depression or cyclone or low pressure. We issue one special message, special weather bulletin to the government of Odisha. So accordingly they take action, whatever action they need to take. So this is the way we make first we write in the textual, then next. In the text we write everything in this next. Then we put the map also, so that by seeing the map orange color people will easily understand. Layman also will understand that the orange color warning is given or red color warning is there. People they should take it very seriously when orange warning or red warning is given. So next. So in our bulletin everything is mentioned. Fisherman warning, port warning, heavy rainfall warning, the graphical format, texture format, everything will be there. What action need to be taken and what damage will be there. Everything will be written in one bulletin that we release to the government of Odisha, and we keep in our website also, people can refer. And we share all this our warning map in our Facebook, Twitter, next. All the social Instagram, Telegram, we have YouTube channel, we have WhatsApp channel also, and then we write in Odia also, not only English. Because here Odia people they should understand the forecast and accordingly they should take action. This is with the cloud picture we keep so that people will think that the cloud patch is there over our Odisha, so we should take action. Next. Then nowcast. Finally, wherever the district, I have made it entirely orange color. Entire district, but entire district will not get the thunderstorm activity or lightning. So that is why we issue the nowcast every 3 hours, even if hourly. Hourly we issue the forecast for next 3 hours. 10 o'clock up to 1 o'clock, then 11 o'clock up to 2 o'clock. Like that we issue hourly forecast. So this is the way it is our website. It is updated where is red, where is orange, where is yellow, where is green. Green means no one. So this is written, and there also it is mentioned what will be the impact, what is the intensity of that system, whether severe thunderstorm, whether very severe, if there is hail is associated. So that will create the huge damage. That is why we put in red color or orange color or red color. So accordingly, government can take decision, but it is very short duration, before 3 hours. So if there is any warning is there, all the farmers, all the common people, they can see outside whether development of cloud is there or not. So if they can go to the safer center, so they can save their life. So this way also we give all the radar image, cloud image to the government, state government. Next. So we are giving, we were giving what is the forecast, but now we are giving what the weather will do. Impact based forecast. What is impact expected if there is thunderstorm activity, hailstorm, heat wave or lightning, what impact and what action will be taken. That also we give the forecast. Next. So this is the way we give in all the platform. Next. this is the most important thing. We have a common alert platform, that is CAP. What happened, we upload our forecast in this platform, and Odisha government, they have one Satarka, and they fetch the data and they issue this kind of message to all the mobile of impacted area. And after the as per the IMD's information, we are likely to get rainfall, thunderstorm or lightning for next 3 hours. So people also might be getting some messages regarding rainfall or weather updates. So this way, this is the IMD forecast, and OSDMA, they send the forecast to everybody by their app, that is a Satark app. Next. Previous question. No. Then what happened? We give the district wise rainfall, but here in that cap we have the provision. We choose that, pinpoint that particular area. Here we have marked this particular area, not district. Area is going to be affected by the thunderstorm, lightning, or heavy. So since this area is marked, the mobile number belongs to these areas. People, they are staying in this area, they will only get the message of weather warning. Next. This is the Satark app. This app is developed by OSDMA, Odisha Disaster Management Authority. So they send the bulletin to all the mobile numbers. Next. Whatever we give the forecast, whether it has been realized or we have gone wrong, we have to rectify. So we also give the realized data. We upload this data also in the every social media platform, where we have given the heavy rainfall warning, whether it has been realized or not. If it is not realized, not realized. Because forecast is forecast, it cannot be 100% correct. So next. So this is the way Odisha government takes all the briefing of weather from IMD and they take the decision. Next. These are our website and app. One can follow and see if they are interested to know about the weather. These are the app, Umang app. In the Umang app, all these apps are integrated. I hope that's all. Thank you. If any questions, yes.
Ma'am, I have a question that why maximum number of cyclones are created in the Bay of Bengal region as compared to the Arabian Sea?
Actually, Arabian Sea, the sea surface temperature is comparatively lower than the Bay of Bengal. That is one cause. Another cause is there, Pacific Ocean. Lot of cyclone forms. They move westward and they cross this Malaysia, Indonesia, all these things. Then they are inland. Also, they come to the Bay of Bengal. That is why number of the cyclone over Bay of Bengal is. Because whatever they form over the Pacific Ocean, they also move and they weaken whenever they cross the land. Again, they come to the Bay of Bengal. That is why number is higher.
Thank you.
Madam, we talked about the number of models actually, and several models we run and predict something. What are those models actually you are referring to?
We are referring global forecasting model. We are referring income model. We are NCMRWF model.
These are all numerical models.
These are all numerical. We are European model. We have multi-model ensemble model we have, and the WRF model we have. We have that implement office model we have, and that Korea model also, Japan model also. So all the models we refer.
So all these models are at the disposal of IMD to run it on.
Yes, that we have the collaboration, and we share our model with them. They share their model with them, and their model also we are running in our IMD by using our initial data. Our data, input data is ours.
One more thing, madam, like you said, the latitude and longitude and there is a forecast is possible there.
Yes.
But you have very limited observatory stations in Odisha.
Yes.
So how do you correlate? Is it interpretations or something other things?
See, even if we see the land area and ocean area though we don't have much data. we always rely on the remote sensing data like satellite data and radar data. Those data actually huge data of satellite and radar data, they are used for the numerical weather prediction than that of the observatory.
But any latitude and longitude points.
So thank you, madam. Thank you so much. Madam, please.